Hello everyone, welcome to this Cisco demo for a hybrid cloud solution using Cisco Intersight, Cisco HyperFlex, Amazon Web Services, and Red Hat OpenShift Container Platform. In this demo, we will look at how the solution delivers an enterprise-class platform for developing and deploying your cloud-native applications across a hybrid cloud environment. This is one of several hybrid cloud solutions that Cisco offers. For more information on other hybrid cloud demos, CVDs, and a pointer to our automation GitHub repo, a resources slide is provided at the end of this demo for your reference. Hybrid cloud is now the de facto deployment and operating model in most enterprises due to the several advantages that this model offers. This, coupled with a shift in organizations towards modern applications using cloud-native, microservices-based architecture and containers, has led to two common use cases in enterprise hybrid cloud deployments. The solution and the demo we're going to look at today addresses these two use cases. Future demos will address other hybrid cloud use cases such as backup and restore and workload migration between public cloud and on-prem locations. So let's take a closer look at these use cases. The first use case is where enterprise organizations, for their cloud-native application efforts, need a consistent application development environment across their on-prem and public cloud infrastructure. These organizations need a hybrid cloud platform where they can quickly and easily spin up Kubernetes clusters anywhere for their application development work. This could be for new applications or for existing applications as part of an application modernization effort. The platform ideally should provide development and operations team with a consistent development, management, and operational experience. The second, which we will refer to as the dev test use case, is where an organization may have multiple teams working on a project and need multiple environments for different stages of their build-release pipeline. For example, they may develop and test in the public cloud, but then stage and deploy that application into production in their on-prem data centers. Enterprises may do this in order to have more control over their business-critical applications and data, or for security and/or compliance reasons. A high-level overview of the solution that addresses the two use cases is shown here. A hybrid cloud deployment typically consists of three components: an on-prem location, a public cloud, and a management layer that deploys and manages the environment. The on-premise location can be any enterprise data center or edge location and connects to the public cloud using secure network connections, either over the internet or using dedicated connections. Now let's take a closer look at some of the key components in the solution. Cisco HyperFlex provides the on-prem compute and storage resources in the solution. HyperFlex is a highly resilient, highly scalable, hyper-converged platform capable of supporting an organization's most mission-critical and performance-intensive workloads. HyperFlex systems with Intel Xeon scalable processors is certified as an Intel Select solution for hybrid cloud deployments. HyperFlex is engineered for data integrity, reliability, and availability to ensure business continuity and data protection. HyperFlex continues to focus on system security. Some of the security features in HyperFlex are data at rest encryption, security-hardened APIs, secure boot, native software encryption, and many more. HyperFlex is also a very flexible platform that can be deployed anywhere from enterprise data centers to edge locations. It is available in multiple configuration options such as HyperFlex Edge and Stretch Cluster to support the different use cases that an enterprise has. HyperFlex also supports multiple drive types and node types with the flexibility to independently scale compute and storage. HyperFlex can be deployed and managed from the cloud using Cisco Intersight to quickly deliver software-defined compute and storage to any enterprise location in a matter of hours. Cisco Intersight is an infrastructure management and orchestration platform that can simplify hybrid cloud deployments. Intersight provides centralized visibility with unified operational control over all Cisco UCS and HyperFlex systems that an enterprise has anywhere in the world. It provides an efficient way of deploying, managing, and upgrading these systems wherever they're deployed. Intersight also simplifies operations by delivering it as a SaaS service with global reach, AI-powered intelligence, connected tag, and other features such as HCL checks, upgrades, software advisories, health checks, and many more. To deliver a hybrid cloud platform for cloud-native workloads, the solution uses Red Hat OpenShift Container Platform to orchestrate and manage the Kubernetes clusters so that application workloads can be deployed anywhere, either on-prem or in the public cloud. Red Hat Hybrid Cloud Console provides a consistent unified management experience in a hybrid cloud deployment. Red Hat OpenShift provides enterprises with complete control over their Kubernetes environments. Red Hat OCP can be deployed on bare metal, virtual, private clouds, or public clouds. Red Hat OpenShift can also be deployed as self-managed or as a fully managed service in both on-prem and public cloud environments. When self-managed, OCP can be installed and deployed using the Installer Provisioned Infrastructure method, or IPI, or User Provisioned Infrastructure method, or UPI. IPI does a full-stack automated deployment of OCP. Regardless of the operating model used, Red Hat OpenShift provides a consistent experience for the developers and operations teams that use the environment. In this solution, OCP clusters are deployed on Amazon EC2 instances and on virtual machines running on Cisco HyperFlex. OCP is also self-managed and use the IPI method for installing and deploying the clusters in both hypercloud locations. To provide persistent storage for the stateful workloads deployed on-prem, the solution uses HyperFlex CSI deployed directly from Red Hat's Operator Hub. HyperFlex CSI is a Kubernetes CSI plugin that allows developers to dynamically provision persistent storage from HyperFlex for stateful container workloads. HyperFlex CSI uses standard Kubernetes objects such as persistent volume claims and storage classes that Kubernetes developers and operators are very familiar with. CSI plugin can be deployed with the push of a button simply by searching for the HyperFlex CSI in the Red Hat Operator Hub and then clicking Install. Once the CSI is deployed on the OCP cluster, any stateful application can request and use storage as needed. The on-prem data center fabric in the solution is a Cisco ACI fabric. The HyperFlex systems in the solution connect into this fabric. The solution can also use a Cisco NDFC managed VXLAN EVPN fabric or a more traditional VPC-based network using standalone Nexus switches. An enterprise with multiple data center fabrics, either ACI or NDFC managed VXLAN fabric, can leverage Cisco Nexus Dashboard Orchestrator to orchestrate and provision the fabrics and the connectivity between them from a central location. When using Nexus Cloud Controller to extend and manage the networking into the public cloud, NDO can also provision the connectivity between the on-prem fabric and the public cloud in a hybrid cloud deployment. To interconnect the on-prem data center to the public cloud, a secure IPsec VPN connection is deployed in this solution. Cisco offers other connectivity options to interconnect hybrid cloud locations such as SD-WAN or by using NDO as mentioned earlier. Note that NDO can automate this provisioning when Nexus Cloud Controller and Catalyst 8000V are also deployed in AWS to manage the enterprise's tenant networking. As stated earlier, AWS is the public cloud provider in the solution, though other providers can also be used. The solution uses several AWS services such as Route 53 for DNS, DHCP, load balancers, transit gateways, and VPCs to deploy Red Hat OCP clusters in AWS with reachability to the Kubernetes clusters and workloads on-prem. When the hybrid cloud environment is up and operational, Cisco Intersight Workload Optimizer, or IWO, is deployed to ensure application performance and to optimize the hybrid cloud resources and the costs associated with them. The solution uses Red Hat Ansible to deliver infrastructure as code to accelerate on-prem deployments. Now let's take a look at what we will be covering in the demo. This slide shows the solution that was designed, built, and validated in Cisco Labs. The first step in deploying the infrastructure is to provision the data center fabric. To bring up a cloud-native development environment requires reachability between components both within and outside the enterprise data center. With the network connectivity in place, the HyperFlex system can now be deployed using either the on-prem installer VM or from Intersight. In this solution, we will use Ansible and Intersight to deploy the cluster. Once the virtualized server infrastructure running on HyperFlex is operational, Red Hat OCP can now be deployed. The deployment can be initiated from Red Hat's Hybrid Cloud Console. For stateful applications that need persistent storage, HyperFlex CSI can be deployed in a couple of steps, as the CSI is Red Hat certified and available from Red Hat's Operator Hub. The Red Hat OCP cluster on-prem is now ready for hosting cloud-native workloads. For this demo, we will use the Sock Shop e-commerce app. To optimize the environment and to ensure application performance, Cisco IWO can be used to monitor and analyze the infrastructure and workload. For container-level visibility, the IWO collector must be deployed on the OCP cluster. With the on-prem environment in place, Red Hat OCP can now be deployed in AWS using the same IPI installation method. The installation for AWS is also initiated from Red Hat's Hybrid Cloud Console. Next step is to provision the network both in AWS and in the on-prem data center to enable connectivity between the OCP clusters in both locations. The OCP cluster in AWS is now ready for deploying cloud-native applications. The same Stock Shop e-commerce application is deployed on this cluster for this demo and solution. IO Collector can also be deployed on the OCP clusters in AWS to enable container-level monitoring and analysis, and to ensure the performance of the application workloads deployed on the cluster. Now let's take a look at the demo. The first step in bringing up a Kubernetes environment on-prem is to configure all the required networking. We will do this using Ansible. The Ansible scripts are maintained in a GitHub repo. The resources slide at the end of this demo will include a link to this repo. The parameters that the user must provide before executing the script are in the inventory group vars directory and under a subdirectory called Data Center Fabric. The script we are now executing will provision the networking necessary to bring this environment operational in an existing data center fabric. For example, the HyperFlex servers will need access to the internet so that Intersight can install and provision the HyperFlex cluster. Similarly, the OCP installer workstation will need access to the hybrid cloud console to download images and other files that it needs for the installation. The installer will then need reachability to the HyperFlex cluster and VMware vCenter in order to deploy the OCP cluster. Both HyperFlex and OCP and the workloads hosted on the cluster will also need access to network services such as DNS, DHCP, NTP, etc. So the script will configure all this. Next, we will deploy the HyperFlex system that provides the software-defined compute and storage for the on-prem location. We will use Intersight and Ansible to deploy HyperFlex. The Ansible playbooks for this are also in the same GitHub repo as the networking scripts. The system we're deploying here is a 4-node HyperFlex standard cluster. The 4 HyperFlex servers in a standard cluster connect to a pair of UCS Fabric interconnects, which then connects to the data center fabric. UCS Manager running on the FIs manages the HyperFlex servers, and Intersight provisions the HyperFlex cluster through this UCS Manager. To deploy HyperFlex, the UCS FI must first be claimed in Intersight. This Ansible script will connect to the FIs and collect the necessary information and claim the FIs in Intersight. Once the FIs are claimed, Intersight has an inventory of all the servers that connect to it. The script will then collect this information from Intersight and dynamically update the Ansible inventory file. Ansible will use this dynamic inventory to deploy and provision the HyperFlex cluster through Intersight. The scripts give an option to validate without deploying or to validate and deploy. The parameters that the user must provide for executing the script are in the inventory group vars directory under a subdirectory called Cisco HyperFlex. Once the install is kicked off, we can monitor the status of the install directly from Intersight. The install itself will take some time to complete, but most of it is unattended. If any failures occur, the install will stop and you will have to correct and restart. If you've met all the prerequisites outlined in the Cisco documentation and the validation checks were successful with no errors or warnings, then the install should complete successfully. Note that the install will implement best practices and deliver a fully functional, hyper-converged virtual server infrastructure platform that is ready for deploying applications, either traditional or cloud-native, making it simple and easy for IT and DevOps teams to quickly spin up a new cluster, making this an ideal platform for hybrid cloud deployments. Next, we will walk through the different lifecycle management capabilities that Intersight offers. From Intersight, you can view any alerts that you might have on the system. Under Requests, you can display the status of certain Intersight actions. For example, the install we just did, we can see the status of that install request here. We can also get software advisories. If Intersight detects you're running an older version, it will give you guidance on a version to upgrade to. You can also get detailed information about the hardware and software components in your cluster. From a storage management perspective, you can manage your data stores and take actions such as create data stores, mount data stores, delete data stores, and so forth. You can also get disk level information where you can view the type and status of the disks that are attached to the HyperFlex cluster. For capacity planning, you can get information about the current trends and get predictions based on your current usage that you can use in your planning. You can also monitor and view your storage performance from Intersight. Specifically, you can get information about the IOPS throughput and latency for the cluster. You can also run periodic health checks and confirm that the cluster is indeed healthy. We're now ready to deploy Red Hat OCP on the HyperFlex virtual server infrastructure that we just deployed. To deploy the Red Hat OCP cluster, we will go to Red Hat's Hybrid Cloud Console. From here, we'll go to Create Clusters and go to the Data Center tab to create the OCP cluster in the on-prem location. We will use the recommended installer provisioned infrastructure for this deployment. Next, we'll download the command line installer, the pull secret, and the command line tools that we will need for this installation. A link to the OCP documentation and a command to initiate the install is also provided here. Next, we will set up the prerequisites that we need before we can start the install. The first prerequisite is configuring our DHCP scope for the OCP cluster. We also need to configure common DHCP options such as default gateway, domain name, DNS server, and NTP server. Next, we create two DNS records, one for the API address used to access the cluster API, and a second one for the ingress address used for cluster ingress traffic. Next, we download the vCenter root CA certificates, copy them to the System Trust directory on the installer machine, and update them. The last step is to generate an SSH key pair to access the cluster nodes. You are now ready to start the installation process from the installer workstation. The installer will prompt you for several pieces of information that you've already set up. For example, the installer will prompt you for vCenter login credentials, the name of the vSphere cluster, data store, and VM network it should use. For the OCP cluster itself, you have to provide the API and the ingress server IPs that you configured on the DNS server, a domain name for the cluster, and a name for the cluster itself. Lastly, paste in the pull secret, and now the installation will start. Once the installation completes, you can export the kube config and access the cluster nodes to verify that they are healthy. To ensure that the master nodes and the worker nodes, which are VMs in the vSphere cluster, to ensure that these nodes are evenly distributed across all ESXi hosts in the cluster, we will set up some VM host affinity rules to ensure that each master node is distributed across a separate ESXi host, and then we will repeat that same procedure for the worker nodes. Once this is complete, we will go back to the Hybrid Cloud console and verify that the cluster has registered with the Hybrid Cloud console. From there, we will log into the console of the cluster itself and verify that the cluster is up and operational. We're now ready to deploy HyperFlex CSI for container workloads on-prem that require persistent storage. First, we create an iSCSI network on the HyperFlex cluster for the persistent data. We then go to the OCP worker nodes in the cluster and enable the iSCSI daemon. We're now ready to install the HyperFlex CSI operator from Red Hat's Operator Hub. The CSI has been certified by Red Hat and is available for install with a click of a button. We need to now collect the access token for the OCP cluster. We then configure the HyperFlex CSI driver with the access token, the online registry info, and the iSCSI endpoint URL. The last step in the process is to create a storage class for HyperFlex CSI. Any workload deployed on this cluster can now use the HyperFlex CSI to make persistent volume claims. The deployment of the on-prem container environment is now complete. We can now use this OCP cluster to deploy a container workload. For this demo, we will use the SockShop app. The SockShop app is maintained in a GitHub repo. We will first clone that app from the repo. We will then create a namespace for this app and use the YAML file to deploy this application in that namespace. Once the SockShop app is deployed, we can then go to the cluster and verify that the app was deployed successfully. We will then need to enable external access to the app so that users can access it. We can now use a web browser to access the app. We have now completed the deployment of the on-prem portion of the solution. To provide a similar cloud-native environment in the public cloud, we start with deploying Red Hat OCP. We start with OCP because unlike on-prem, the underlying infrastructure is already in place when using a public cloud provider. We will use the same hybrid cloud console that we use for deploying OCP on-prem. We will need an installer machine to do the install with access to the hybrid cloud console and to the tenant VPC where the OCP cluster in AWS will be deployed. Here we will use an AWS EC2 instance as our installer workstation. From the hybrid cloud console, we go to OpenShift, Clusters, Create Cluster, and then use the Cloud tab to scroll down and select AWS from the list. We will use the recommended installer provisioned infrastructure, just as we did on-prem. Here we'll download the installer, copy the pull secret as well as download it, and download the command line tools that we will need. Once the download is complete, we can use this command to initiate the install of the OCP cluster from the EC2 installer. Next, we need to take care of the prerequisites that we need before we can start the installation process. Red Hat OCP on AWS requires a base DNS domain to be defined. We will use Route 53 for this. Next, we need to generate a SSH key pair so that we can access the OCP cluster nodes. To set up a base DNS domain, we will use Amazon's Route 53 for this. To set up the SSH key pair, we can use the command shown here. We're now ready to start the installation process. The installer will prompt you for some information before you can start the installation process. The first being the SSH key pair that you generated. Then you select which public provider you're using. Specify the AWS region where you'll be deploying this. Specify the base DNS domain that we want to use for this OCP cluster. This is the Route 53 domain that we configured. Provide a name for the OCP cluster. Lastly, you paste the pull secret that you copied from the Hybrid Cloud console page. At this point, the installer will begin the installation process. The last step is to export the kube config, verify that the cluster is healthy. The next step is to deploy a cloud-native application in the OCP cluster. We can use the same Sock Shop app that we used on-prem. However, since the deployment is identical to the steps we followed on-prem, we will not repeat that again here. The only difference here is that we're using an AWS EC2 install workstation to clone the app from GitHub repo and to deploy it on the AWS OCP cluster. The last piece of this deployment is to optimize the cloud-native environment in both on-prem and in the public cloud using Cisco IVO. In this demo, we will look at how we can utilize IVO to assure application performance, manage resource consumption, and reduce costs. IVO uses the on-prem and public cloud targets in Intersight to collect information from the two environments. IVO uses this info to build an interdependency map of all components, giving us full-stack visibility into the applications and infrastructure in each environment. The components and dependency mapping for this solution is shown here. You can also view the on-prem and public cloud environments separately. IVO uses historical and real-time data to make actionable recommendations on what changes should be made, why, and what the cost savings are. For example, for the AWS OCP deployment, you can view all the actions that IVO recommends that you take and the cost savings associated with it. IVO also provides additional details on each recommendation that it makes. You can also look at similar information but from an application or workload perspective as shown here. We have now completed the deployment of an end-to-end hybrid cloud solution. The enterprise now has two cloud-native environments, one on-prem and one in AWS, that they can use to host and develop applications. The two environments can be centrally managed from Red Hat's Hybrid Cloud console by developers and by IT teams, giving both teams a consistent development and operational experience in a hybrid cloud deployment. Additional clusters can be deployed in either location to support the dev test use case. In future demos, we will look at other hybrid cloud use cases such as backup and restore and workload migration between public cloud and on-prem. This concludes this demo. Thank you.